Hello, everyone. In today's cloud-native world, every API call, every microservice interactions, or every data access demand authorization that happens at split second. Yet, in this new world, many of our modern applications are still suffering from the rigid, monolithic RBAC hierarchies. And today, we do have mechanisms to future-proof our applications. Then why are we still thinking about static roles? Well, looking at you, I can definitely tell you are thinking beyond static roles. That makes you come here, right? Hello, everyone. Myself, Momita Saha, a Senior Security Partner SA at AWS, and I have with me.
Hey, hi, I'm Abhishek Pandey. I'm a product manager with Cedar and Amazon Verified Permissions, which we'll talk about in more detail today.
And together, today we are here to walk you through a journey from role-based access control to policy-based access control, and how this can help us future-proof our applications. So let's scale beyond RBAC. Coming to the agenda, we will start with RBAC, a brief introduction of RBAC, the challenges that we have been seeing in the industry with RBAC, and then moving on from there with the new age policy-based access control, how to implement policy-based access control with some of the services that we provide at Amazon and beyond. We will do a code walkthrough of how to define the policies and go from there. And then finally, we will summarize with the challenges of RBAC being solved by PBAC. And finally, at the very end, we also have a code repository which we would love to share with you. And there you can go and see all the policies that were used in our talk. Role-based access control. Role-based access control gives us the mechanism where we don't have to give direct access or direct permissions to individual users. Role-based access control is where we have an intermediary called roles or user groups. We are now not giving individual users permissions to a resource, but we are trying to do it via an intermediary role. In an ideal world, this is very efficient, simple, and it works perfectly. Where someone like Alice wants to get access to an S3 bucket. Now, instead of giving Alice direct access, we put her in a user group, say data analyst role, and then give that data analyst role access to the S3 bucket. Now, what's happening currently is this, where we are trying to give not just Alice, but different data analysts access to the environment. Now, with time, your analyst roles also evolves. Now you may have a senior analyst and a junior analyst. So that is where we kind of expand on the role, which tends to explosion of the role, and we are creating multiple versions of ultimately the same role. And that brings us to the challenges of RBAC. I'm sure you might have experienced some other ones than what we have, but just from our experience, we can summarize 5 fundamental challenges, starting with role explosion, what we just saw on the screen, in the previous screen. Second being permission creep. We start with certain permissions to our role, but then as our business grows, we need to increase the permissions, and that adds on to the permission creep process. Third, being a lack of centralizations. Yes, we have an authorization environment where we can write multiple roles, but imagine when we scale our organization and we have multiple applications, then we have to do it specific to the applications, and that breaks the centralization process. Fourth, being poor scalability, where the growth is linear, and so is the complexity. And then finally, auditing. When you write application authorization logic within the application, you are missing out on doing the auditing of just your authorization. We have to now review the entire code of the application to review the authorization. Now transforming from this role-based access control to policy-based access control. What's the big difference? Now we are trying to write the permissions as policies. Is it just another way of writing permissions? Well, yes, but the good part is here we are not trying to reinvent the wheel. Rather, the concepts that we had, we are just trying to expand and add on to those contexts. How? So policy-based access control gives us the opportunity to write the permissions as policies, and then these policies can now be doing the authorization evaluation of your application. The very big thing that it takes out from the application code is the authorization logic. Now you don't need to write the authorization logic inside your application. You can write it outside, and there is a dedicated engine called the authorization engine, which will evaluate your authorization logic by evaluating those policies. And all of this can happen in a central store where all the policies are getting stored. The other big part of policy-based access control is the dynamicness that it brings. In role-based access control, we had a model where you can give static roles. That model still stays in policy-based access control, where you have the admin time authorization, where the admin can define static roles, but with a dynamic access control towards it. And that is being added with attributes. Who can access what can be determined by that person's attributes, which can be the context metadata. And that will determine what static role that they are assigned to can do. But the interesting part is the runtime authorization, which is the add-on to dynamic access control. With runtime authorization, now your developers or the lead developers can give access right when your application is getting used by your end users, just by looking at the context metadata and also some attributes, runtime attributes like time, date, location. You can add that to the authorization logic, and that is how it can become dynamic authorization. To do this and to make it simple, we have introduced Amazon Verified Permissions. This is an authorization as service, which uses the model of doing policy-based access control. Now, if you're thinking that if I move on to policy-based access control, do I have to define my authorization logic? Do I have to define the authorization engine? And also, do I have to maintain this store, the policy store? Well, that's all that verified permissions can do for you, and just leave you with writing the policies, because the policies can be written which is integrated or aligned to your business logic. So you can only focus on writing the policies that are appropriate for your business and how your application should behave based on your business logic, and then rest will be taken care by verified permissions. And how we do that here? You have an API endpoint or an enforcement endpoint of your application. From there, you make an authentication request to the IDP, and then when you come to the authorization, you ask for accessing your application resources. This goes to verified permissions. It checks the policies that are defined, be it runtime or the static policies that are there. And based on the policy, it will tell you whether you are allowed to access or not. This adds the fine-grained authorization that we demand in policy-based access control. A quick overview of the architecture, and this is all we are going to show you with the policies. Abhishek is going to walk you through the code on that. But before we jump onto the code and go through it, let's do a quick brief on the architecture, how Amazon Verified Permissions works. As I was saying, the basic way of application access starts with an authentication, which can be your chosen identity provider. It can be Amazon Cognito or your own OIDC of choice. Next, when you get the authentication, in the ID token, you have the detailed context of the user who is trying to access. With that, you make a call to the endpoint to reach out to the end resources. Before reaching out, this is where verified permission sits. There is a Lambda authorizer that will do the call to verified permissions, and the verified permission engine will evaluate the policies, find out if it is allowed or denied, give the response to the authorizer, and that's how you get the access or get denied. Cedar. Now, one of the backbone of policy-based access control, particularly in verified permissions, relies on the policy language that we use, Cedar. Unlike being a very new language that you have to learn from scratch, Cedar gives you the opportunity of combining a programming language concept along with the IAM policies that you have written. How many of us have written IAM policies? A show of hand. Fairly all of us know how to write a IAM policy. How many of us have written programming languages or coded in programming languages? Great. I think we have the perfect audience today. So that helps us write a Cedar policy. You don't have to learn something new. If you have to break down Cedar policy, there are three big components: effect, which is very similar to our IAM policies. In IAM, we call it allow or deny. Here, we call it permit or forbid. The scope, that is where we are defining who can access what based on what actions. So the principal, action, and resource. And the third being the conditions. Now, this is where the flair of programming language comes into the play. Here, unlike identity policy, here we can give those user attributes or the group attributes that we want to add the context to our application authorization. And that will take us through the policy evaluation. Now let's migrate an application access control. Many of our modern applications are still running on RBAC. How do we change it to PBAC? We have a sample application created, and that is called Pet Store application. We have kept it simple. There are two different user group categories or roles, customer and store manager. Say, as a customer, you would like to see all the pets in the pet store and go into the details of the pets. But then you are not allowed to create a new pet or delete a pet, which the store manager can. And here we will show in the demo how these two roles have different permissions, and this is all through role-based access control. Abhishek is going to do the fun part with policy-based, but I'll keep it with the traditional approach. How many of us has done a workshop or builder session on Cognito, where you have seen Wild Pets store? Okay, some of us. So we are not reinventing the wheel in the application. It's the same Wild Pets application that you might have seen in the workshops. The key focus here for all of us is to make sure we are seeing how the authorization is happening, not just the authentication, but the focus is authorization. So right now, I have not signed in, and I'm not authenticated. So let's see if I can view the ID token. There is no ID token. And can I call any of the services. Well, I cannot. What are the services? So in this pet store, we have the options of listing a pet, which will give all the pet details, getting a particular pet's details, then moving on to creating a pet with the post ID, and then finally deleting a pet. And as you can see, we could do nothing without signing into the store. So the authentication is secured. Now let's get authenticated. Julian.
And then one thing, one of my colleagues has talked about this as these last three things.
So I just signed in as a user. Now let's first find out what type of user I am. If you view the ID token, I have signed in as a customer. And according to the table that we saw previously, I should be just able to view all the details of the pets and get a particular pet details. But if I try to delete this pet, access denied. Now, all this is happening right now with role-based access control, where the authorization is done via IAM policies. The big concern that we have been seeing here is when we look at the code, when you are trying to give access to an application and you are trying to do the authorization in your application, you have to define the application's authorization within the application code. As you can see here, in this authorization piece, I just took a snippet of the application code where we are writing the different conditions that if the user group is manager, then I will give this much access. And that is done in an if-else block, and all of this is written inside the code. Now just imagine doing this from the perspective of auditing. Now for auditing this authorization, you have to review the entire application code. Now let's implement this whole application authorization with AVP, or Amazon Verified Permissions, and I'd like to hand it over to Abhishek.
Hey, thanks, Mamita. Quick intro again. I'm Abhi. I'm a product manager with the service. So what are we going to do here? So we're going to re-implement the whole application again, and nothing changes from like a customer-facing standpoint right now with Cedar and verified permissions. So before we go into actually implementing it, let's just quickly go over the high-level diagram that Mamita shared earlier and try to break that apart a bit and see what are we going to work on. Okay, so this is the diagram that was shared earlier. It's fairly simple. First step is authentication. You could do it with any OIDC provider. You could do it with any provider, actually, as long as you know the user. We use Cognito in this application because it's AWS. But typically, after you authenticate, you get back a set of ID and access tokens. Right? These contain user information. Now, something to zoom in on is this field, these two fields, groups and the store ID, right? So roles in general, I've seen customers kind of manage roles or figure out which user is in which role in different ways. One common way is groups, which I've used in this application. I've also seen customers capture roles in terms of user attributes, sometimes in their own databases, so on and so forth. Again, verified permissions pretty much doesn't care about it as long as you can pass it the information of which role the user is in. So that's what kind of happens next. The ID token is passed to API gateway, which in an unauthorized world would have just directly called backend APIs. But we're not going to do that. We are safe, secure. We are in a security conference. And so we introduced a Lambda authorizer in between. What does this Lambda authorizer do? It takes the API request, calls verified permissions, and checks whether that request is allowed or denied. If it's denied, it sends it back, else it forwards it to the backend APIs. So this is kind of what it's doing. What does it take? Well, it takes a few more things. So in verified permissions, you would want to create 3 things. One, you want to create the policies. You want to create the schema. So to start with, you need a schema which describes the resources in the application. Right? So for a banking application, that might be the user, the bank account, and so on and so forth. We'll see what it is for the pet store. Second, you want to define policies, policies that specify who's allowed to access what. So those 2 components. And third, you need like that Lambda authorizer layer, which basically talks to both services and orchestrates. So let's get into that. Let's get into a little bit of coding. Let me switch over to my laptop and actually show you how I've coded all of that. So this is the application. And then I'm going to switch over to Visual Studio Code, where I have a bunch of my code written. So 3 things, right? We'll start with the schema. What is the schema? How many of you have actually used Cedar and verified permissions, heard about it, read a bit? It's nice, few of you. It's encouraging. So let me just walk you through slowly over what these things are. So in this case, it's a pet store. And so what does a schema do? Schema defines all the entities of the system, all what are permissions based off. It tells verified permissions what all things are there in the system. Think of it like classes of Java. That's like a good analogy. So in this case, I have one entity for the user. That's just the user. It does a little bit more. It tells us which attributes the user has. So in this case, there is an attribute called store, which we'll look at later on why it's used. And it has an attribute called user group, which is, a parent entity called user group, which basically specifies what role it's in, right? So those are the user entities. Similarly, there's a pet entity, because guess what? We have a get pets API. We also have a store entity, which store is the pet in. And then we have an application entity, which is kind of a Uber entity that just encapsulates everything. So that's kind of all the entities in the system. We also define what actions these entities can take, right? So in my case, I've defined like 4 actions, 1 for each API. So I'll just look at one. So the first action is a get action for getting or listing pets. So it's a get. So it's fairly simple. I just concatenated the method and the path, the HTTP method and the HTTP path. And so that's my action name, and kept it fairly simple. I also specified who is allowed to act on it. So a user acts or calls this API on a resource of type store, because I'm trying to list all pets of a particular store. And then similarly, I have one for each of the other APIs that I had. So that's my schema. My schema is telling me these are the entities, this is how they interact with one another. OK, so once I have a schema, I am now ready to create my policies. So what are policies? Policies are going to specify who can do what in the system. For now, my system has 3 policies, 1 for the customer and 2 for store managers. OK, so let's quickly go through the customer policy. So what is the customer policy saying? So first statement, permit. Right? So this is exactly like IAM. By default, nothing is allowed. If I have a store with no policies, everything is denied, but that's not useful. So I'm going to allow anyone. So I'm going to permit principal in this user group called customer, so anybody who's a customer, to take these 2 actions, which are the get actions that Momita had called earlier. And I keep the resource, which means the resource could be anything, right? Irrespective of what the resource is, anyone in the customer group is allowed to call these 2 APIs. And so policy makes sense. It's fairly simple. I have similarly 2 other policies, one for manager read actions. So this is kind of the read one, which is fairly similar. It's just the user group that's different over here. And then another policy for write actions, which specifies the delete API for deleting pets and the create pet API, which is a post. OK, so this is kind of it. These policies, once you save it to verified permissions, it automatically validates it against your schema. So if I had made a typo here, the schema validation would have caught it and told me this policy is not valid. The other thing you'll notice is these policies are deployed through CloudFormation. So I just have my CloudFormation script here, which contains these policies. So they can be managed with Terraform, CloudFormation, CDK, infrastructure tool of your choice. In a typical application, I would also put this in the file and just import it here. But for the purpose of the demo, I kept it simple, everything in one place. So those are my policies. So two things out. Now, the last component. The last component is the part that talks to API gateway, calls the service. OK, so there what's interesting is what is the actual API call, right? How do I end up calling verified permissions? So that requires a few things. And then we'll see an actual input. This is just my code for calling it. So the first thing it requires actually is a policy store ID. Which policy store am I triggering this query against? What's a policy store? It's a combination of policies. The other one, the next one, is actually this token type, which is the principal I'm passing. I don't actually have to validate the token or unwrap it or anything. I can just pass the token. In this case, I pass the identity token to verified permissions. It validates the token, checks the signature, checks the expiry, and gets all user attributes right out of the token itself. I need to pass the action, and I need to pass the resource which is the API is acting on. So let's actually look at an input. Let's look at a concrete input. OK, so I ran one, and I pasted that log here of what an authorization request looks like. So the first thing is fairly simple. It's a policy store ID. The second thing is the identity token. So this is what will match the ID token in the application we saw. The action is, again, it's an action. And this one's for the GET API. So I specify the action. The resource is the pet. So I'm trying to get details for pet 22. So that's kind of the action I'm trying to show. Right? So the entity ID is the ID of the pet. And the entity type is the fact that it's a pet. And the entities list allows me to specify more details about the principal and resource. So in this case, in addition to just specifying this is pet 22, in the entities, I've also specified that pet 22 has a few more attributes, specifically what's the price, what's the type, and which store it's in. So that's my authorization request. Great. There's nothing new to show per se in the application. It's all the same. Right? No changes. Everything's just working as it is. Right? So let me switch back. Now that we know how this is implemented, let's just quickly go back here and then talk about this. So I re-implemented it, and I said there are no customer changes. And a PM like me will come back to you and say, why? What's worth the switching cost? Right? That's kind of a very fair question to ask in this scenario. Or if you're building from scratch, you're like, should I learn a new technology for this? That's a very fair question. But now let's see what are the advantages this gains, right? So I'll talk about a couple of things which I've seen a lot of customers get into. So again, this is a wild pet store, and it's widely popular now. And so we expanded from like one city, Seattle, to 50 cities in the US, as an example. And so our operation teams are now basically saying, well, guess what? With 50 stores, we can't have store managers just add pets to any store. Like a pet store manager in New York added a pet to Seattle, which they actually don't have. That's not really good. And so they want to restrict what store managers can do to only the stores that they work in, which is like very logical, very reasonable. And so in a very traditional RBAC sense, what would we have done? We would have created one role per city, and suddenly we would have 50 store manager roles, right? A typical example of role explosion. One of our customers have told us, like, we had more roles than users. Imagine that. How many of you have done this in the past? Like, I definitely have done something like this. So, OK, great. So now let's see how verified permission kind of solves this. Right? So again, I'm going to be switching a bit. So I switch back, and I go back to my Visual Studio Code. And so what I'm going to do is I'm going to change the policy for a manager. So I'm going to kind of comment this out. And I cheated. I basically have one ready. And let's just quickly go through it. OK. OK, so this is the policy for a manager now. So in this policy, this part pretty much remains the same. So I'm still going to permit anyone who's a manager to delete and create pets. So these are the two APIs. The additional bit, or the interesting bit, is this when clause. So what's the when clause saying? The when clause is saying a few things. So when clause is trying to ensure you can only do it in the store you work in. So it's saying as long as the resource and principal has a store ID, they need to match, and only then will access get granted. So the resource.store ID is the pet store ID, or the actual store ID for the store, right? And the principal has an attribute called custom store, which stores which store he's working in, essentially. That's the way kind of I ended up modeling it. And so this policy is ensuring that you can only change things or add pets or delete pets to the store you work in. Let's actually see this in action. So I'm going to log out as a customer. Great. And I'm going to then sign in. And this time I'm going to sign in as myself. OK, so I am signed in. I'm going to view the ID token. And you can see I'm a manager. I promoted myself. And then I have an attribute called custom store. So I work in store number 1. OK. And this is my fake way of saying I'm going to call this API on behalf of store ID 1. OK, so let's first try the simple thing, which is kind of try to list pets. So I can list all the pets here. Great. I'm going to create a new pet and see if that kind of works. So I'm going to create a pet with pet ID 10,000 something. It's a dino. And I'm going to take $10,000 for it. Great. So pet 1, I'm in store 1. This should work. Let's see. OK, so this definitely worked, right? I can now try delete. And that should also work. Let's actually try it. Hit it. I don't. I'm going to try deleting a different pet for simplicity's sake. OK, so it did work. Right? Now, when I change the store ID to store ID 2, so I try to create like a new pet in a different store. And I'm going to just say like 20,000, and it's still a dino. This should. So the submit doesn't work.
Live coding.
Yeah, this is the problem sometimes. Oh, I know what happened wrong. I didn't deploy it. So let's actually do that. No operations updates because I didn't save it either. So it proves that I actually am live coding. I don't have it recorded. So let's quickly look at this. So once it's updated, it shows up here. So if you now look at the policy, it actually has this when block, which it didn't have earlier. So now let's try to submit this. And this, I'm going to just change the pet ID for simplicity's sake. And so, yeah, I get an access denied because, well, this is not allowed. And then very quickly doing it again for store 1 because I want to close the loop on this. This actually ended up working. So kind of that's the key. What's the takeaway? The takeaway is I didn't have to create 50 rules. I could edit one rule, one policy of mine, and it's still one rule. It's just my access is more conditional now. So that's one use case for this. Let's talk about another. Yes, so we did try this. Another very frequent thing that my operations teams come back with is we had store manager until now picking things out of the truck and putting it on the shelf. That's good, but it's not scaling well. There are more important things that store managers need to do and manage and so on and so forth. And so we have decided to hire stalkers at our store. What are stalkers going to do? They're going to lift stuff from the truck and put it on the shelves. Right? That's kind of the job of the guy or the girl that we'll hire. We don't want them to give the same access as a store manager. What we don't want to allow them to do is delete pets, right? They are only going to stock things. They're never going to remove things. And so that's kind of the access that we want to give. And so we have to create a role for it. Now, with RBAC, they would have come is, OK, what can I do? Let's see, I go back to the engineering team and ask them to create this role. That's what, and then it gets prioritized. It goes through like pen tests, security tests, so on and so forth. And so it takes time to implement, right? And so we actually don't like that. Like as an engineer, I hated that part of operations. I want it to be quick. I want it to be fast, right? I want business to run and be really agile and not bother me with these tasks, right? So how does, again, PBAC and verified permissions solve that? It's actually simple. The answer lies in let's just create another policy for a stalker that can kind of define what a stalker is allowed to access. And again, we'll create a conditional policy so stalkers can create the pet only in the stores that they actually work in. So let's go do that. I'm going to switch over. Great. So I again go back to CloudFormation, and then I'm going to create two policies. The first one kind of allows the stalker to get the pets, so they're allowed to like create and list and get pets. And another one, which is very similar to the manager policy, which allows them to post, which means create a pet. So they're allowed to call the create pets API. But they're not allowed to call the delete API. So I've not mentioned that there, and by default, that's not allowed. And then I have a set of conditions, which is they essentially need to be in the same store in which they're creating the pet, right? So the resources store ID should map to the principal store ID, right? So that's kind of the underlying condition that I've added. I'm going to save this. I'm going to deploy this. And so what I should see once this CloudFormation finishes is a stalker policy should get added. OK, so a couple of policies got added for stalker. First one just says they can call the list and get APIs. And then the next one basically says they're allowed to create a pet, so post, as long as the store ID matches. OK, so again, doing the same thing, signing out from here. Open the link again, sign in, and this is Mark. OK, so I'm going to go view the ID token. Mark is a stalker and works in store 1. I'm in store 1. And so they can call the get API. I mean, that's totally cool. And then let's create a pet. This time it's a T-Rex. And those go for really expensive, so $2,000. Let's see. And so yeah, this one successfully created. Now let's try to actually delete this guy. So I'm going to call it's the same thing. And so yeah, access is denied because, again, they were a stalker. So these are two good use cases that we discussed where you didn't actually require code changes to help the business move forward, right? And something that's different or which is like seen as a key advantage between like a traditional RBAC system where everything's in code and a PBAC system where you can add policies and modify policies to either restrict access further or create new roles or do different things that operational teams frequently ask of us. I'll now pass it back to Momita. Who's going to summarize it?
Thank you, Abhishek. Can you all hear me? Perfect. So we have seen the journey from RBAC to PBAC, and Abhishek has walked us through the policies in details. Now let's try to match what has been solved, starting with role explosion. We talked about role explosion. And then we saw how the dynamic policy evaluation logic and the attribute-based policies have helped us stop from the role explosion. Next, we saw about the business agility, where the permissions now can be updated without updating the code. You saw how fairly simply Abhishek just wrote a policy and did not touch the application code at all. The centralization. Now, all these policies across your applications can be stored in one central space. And that is what verified permissions is providing us, the policy store. The scalability part. Now we can create hierarchical permissions where under the store manager, you saw there's two different store managers can be there. So that's the hierarchy we can create with verified permissions and policy-based access control. And finally, the auditability purpose. Every API calls that you are making to verified permissions, everything is getting logged into CloudTrail. So now your authorization access logs are also getting separated out from the application code and application logs, and you can dedicatedly now view them for audit purpose. So what do we need to do to migrate the application from RBAC to PBAC? You saw the application, you saw the authentication. That does not change. You can use your own ITP or Cognito, whichever you prefer. The change happens on the authorization piece. Now, currently, you can do it through various options: API gateway, AppSync, load balancing, Cognito identity pool. Some of them are using RBAC. Now, you can also do policy-based access control using some of these options by using AppSync or load balancing. But there, you will have to write the authorization logic. You also have to write the authorization engine that will evaluate the policies. And you finally need to create a centralized space for storing those policies. And that is where verified permissions comes into the play, where it is taking out all those additional activities from you, and you just focus on writing the policies aligned to your business logic. And the rest is taken care by the service itself. And that brings us to the end of our session, doing a summarization of the key takeaways. We saw the benefits, we discussed it. We also tried to show them through some part of the code. We saw how verified permissions can offer a policy-based access control engine, taking out all the additional work from you and only allowing you to focus on writing the policies, and that too using a language which is very much aligned to our programming language world and identity policy writing world. We talked about Cedar. Then we also discussed about how you can now focus on monitoring the policy evaluations directly by accessing the CloudTrail logs, because every API call to verified permissions are getting logged in CloudTrail. Here is the code that you can go and access. I just realized I forgot to make the repo public. So I'll change the repo access to public. You take a screenshot of this and take the code repo. You will see it public in a minute or two after the code talk. And that brings us to the thought. We talked about role-based access control. We talked about policy-based access control, and the work that we need to do to future-proof our applications. Now, it's on us how we want to secure our applications and how we want to give our application builders, developers, and different admin that privilege to integrate the business logic into your application's authorization. So why wait? Let's do it. Thank you all.